Good morning everyone, dear attendees, and welcome to this key session of this Tuesday morning, so the invasive and emerging plant diseases key session. I am Philippe REIGNAULT, one of the co-chairs of this session, and I am from ANSES, which is the French sanitary agency, and I am in charge of the plant health department in this agency. And I have the pleasure to co-chair this session with Nico, who will introduce himself just a little bit later on. First of all, an unexpected information that we've got confirmation about only yesterday evening. So this morning there's going to be one speech, one talk less than previously scheduled and previously expected because unfortunately our colleague Hernan Bourbano from the University College of London, because of some difficult family reasons, could not come over to participate to this meeting, and because of that there's going to be only two talks this morning during this session. So anyway, we keep moving on, and that will be the opportunity for us to optimize some more flexibility in terms of timekeeping, of course, for the speakers, but also in terms of interactions between the speakers themselves and also yourself, the audience. So anyway, the coffee break won't be served before 10 a.m. So of course, again, there's going to be some substantial more flexibility in terms of timekeeping this morning. So this being said, I now give the floor to my colleague Nico, who will provide us with a short introduction about the content of this session, and then we will give the floor to the speakers of this morning. So thank you, and Nico, I give you the floor.
Good morning, everybody. I hope everybody is fresh and full of energy for a new day full of interesting talks and interesting discussions. My name is Nico Horren. I'm the Director General of the European and Mediterranean Plant Protection Organization based in Paris, in short EPPO, and I'm happy to co-chair this meeting with Philippe REIGNAULT today. And I'm also happy to introduce this session. This session is going to be about emerging pests, and we have heard several of them already yesterday coming along in the introduction, in the presentations. And there are a number of threats to plant health, and there's impact on all type of ecosystems increasing over the years. And the speakers that we have today in this session will share their experiences with emerging diseases, the challenges and the perspectives, and also how to prevent outbreaks and to be prepared to react rapidly on the appearance of new diseases, and to protect, in the end, the environment and ensure food security. Because that's what we're working for, to achieve, to contribute to this aim of protecting the environment and ensuring food security. So this is what this session is about. We have two interesting speakers today, and I'll give the floor back to Philippe to introduce the first speaker.
Thank you, Nico. So we are now ready to move to the first talk of this morning, and we will now give the floor to Professor Lodovica GULLINO from the University of Torino. Maybe quite a few of us already know Lodovica, whose career is mainly based at the University of Torino. So Lodovica is a professor, mainly in management of plant disease in the most integrated way, we could say. She's also the director of the Agro-Innova Center of Competence, which is involved in the production of innovative solutions for crop disease management. And Lodovica has been also in the past been the vice president and thereafter the president of the International Society for Plant Pathology between 2003 and 2013, if I am right. And to complete the circle, Lodovica has had also the opportunity to organize this conference, the International Conference for Plant Pathology in Italy, in Torino, in 2008. So as you can see, she has a quite significant past, which is shared with the different subjects of interest of this morning. Lodovica will make a presentation, will share a presentation this morning with us about, of course, emerging and invasive diseases, but concerning quite a wide array of crops, which are, of course, of great interest, and vegetables, with quite a few specificities, with corresponding consequences in terms of characteristics of these emerging diseases, and also in terms of specificities towards the corresponding possible management of these diseases. So, Lodovica, I give you the floor, and it's going to be a pleasure for us to share the data and the knowledge that you're ready to present to us this morning.
Thank you, Philippe. Bonjour, good morning. Thank you for inviting me today. I am very happy to be here in Lyon. Torino and Lyon share many characteristics, are two cities very much linked from a cultural point of view, from a historic point of view, and also from a scientific point of view. There are so many connections between the University of Torino and the University of Lyon in the field of humanities, in the field of medicine. So I'm really happy to be here again because Lyon is a city that I visit very often. When I was invited to this meeting, I selected the vegetable sector because it's a very peculiar sector, a very dynamic sector, and I prepared this presentation together with my colleagues Giovanna Gilardi and Massimo Pugliese. Vegetable production is extremely important. It's a rich sector also in terms of how growers can get back from growing vegetables. It's a very dynamic sector, and in these slides we can see the volume of tons produced worldwide. These are FAO data of 2021, and we also see where most vegetables are produced, China and India. India is growing. And this is one of the characteristics of this industry, which is an industry in continuous evolution in terms of new production areas, new crops that are showing up, new crops and new variety, new products. Let's just consider all the convenient food that we like to use, to buy, like ready-to-eat salad, which is an emerging sector where, for instance, Italy is very strong, both in production as well as in consumption. We have new growing techniques showing up. And of course, this industry, also in connection with its feature, is very prone, I would say, to the development, to the appearance of disease. Why? Because novelty is extremely important. Consumers change their taste. They want new products, new varieties. And so we have continuously introduction of new crops, of new varieties. And there is a continuous turnover in the taste, in the wishes of the consumers, as well in what we grow. Aesthetics is extremely important. This means that in some cases, we need an extra care in terms of disease management. As I said already, we have so many new production areas. We have very intensive cultivation techniques. Many crops grown very often in the same soil or in the same system, and we, as plant pathologists, we know very well what this means in terms of diseases. We have the use of seed and propagation material, which is often produced in few facilities, and generally everything goes well, but if something goes not so well, and we have some contamination of seed or propagation material, this means that we are immediately sending this material all over the world, and this is the way how many pathogens that we did study and see during the past years did spread all over the world. So we have a very strong regional, interregional, extra-continent movement of seed of material that often is produced in third countries with very different weather conditions. And so very often we are importing new diseases. And another aspect is that in this field, also because many vegetable crops are considered and are minor crops, we don't have so many fungicides, so many chemicals available for disease control. And this sometimes can be also a small problem. As I said already, we can have the contamination of propagative material. And seeds are very good vector of pathogens in this area, in this sector, which is, I said, very dynamic. Seeds are moving from one country to the other. And so in this way, many pathogens which can be harbored inside the seed or also only externally. Very often the contamination is external, but this is enough to spread pathogens all over the world. And this is also another way that pathogens use to survive in the soil. In some cases, seeds are also transmitting and spreading strains which are resistant to fungicides. This, for instance, happened in the case of basil, when strains of Peronospora belbari resistant to fungicides were spread. Not so we don't have only the pathogen arriving, but also pathogen resistant to some fungicide. And of course, contaminated seed, we will see later on, talking about disease management, can be treated. But what it is important, and again, later we will see this aspect, seeds can be checked, must be checked, and we have the tools to do this. Just an example of how seed can be contaminated. We see different examples of lettuce, endive, rocket, basil, and we also, this is another important aspect. Very often, it is enough to have much less than 1%, 0.001% of seed contaminated to have very severe losses in the field. So this means that the control, the testing of seeds, and we have session on this topic, is extremely important to avoid the spread of new pathogens. We did work a lot during the past years on disease of vegetables, on how new diseases are spreading. This is a real heaven for plant pathologists because so many diseases are showing up. So from our point of view, it's really interesting. I decided to focus on some aspects. I will focus on Fusarium wilt of leafy vegetables, on Alternaria diseases because they are becoming more and more important, also due to climate change, to the increase of temperature, and on Peronospora, the downy mildew of basil, because it's a peculiar disease. Leafy vegetables are important, especially for fresh consumption. We know how in the Mediterranean diet, vegetables are important. And also we have more and more vegetarian and vegan people in the world. And the leafy vegetables are very often also used to produce the ready-to-eat salad, the salad that we buy in the packages. So are is an important crop. They're important. There are several, from lettuce to rocket to basil to cultivated rocket and wild rocket, chicory, and several. I remember when I was in the States, I was calling all salads. And I was going in the supermarket and say, I buy some salad, and they were telling me, it's not all salad. This is chicory, this is endive, and to me everything was salad. Now I learned that there are different salad crops. And in most cases, the fusarium wields of leafy vegetables arrived in our country as well in other countries with infected seeds. Very few infected seeds, a very low % of infected seeds, very often only externally contaminated, were able to introduce and to permit to this pathogen to spread. As I said, as we will see, seeds can be treated. This is important. An infected seed, if treated with physical, with chemical, with natural compounds or biological compounds or a mixture, can be treated, and so we can eradicate, in some cases, completely the pathogen. I start with Fusarium lactuce. Fusarium oxyspon, forma specialis lactuce, initially called lactucum, is increasingly important worldwide. It started in Japan in the 50s. We talk later about races. It moved to California in USA. Then again in Taiwan. And it arrived in Italy, in Europe, first in Italy in 2001. At the moment, we know 4 races of Fusarium lactuce. Race 1 is the one widespread, present in Japan, in Taiwan, in USA, in Europe. Race 2 and 3 are much more restricted. Race 2 is present in Japan and Taiwan. Race 3 has been only described in Taiwan. And more recently, in 2015, Race 4 appeared. We will discuss a little bit later about the characteristic of the race. Appeared in the Netherlands, Belgium, Italy, and now is spreading in different countries. Race 3, as I said, is only present in Taiwan, has been studied, and is genetically different, and at the moment didn't spread in other areas. It's completely different from the other races. Race 4 arrived in the Netherlands in 2015, then moved to Ireland, Lancashire. In 2018, spread much more in UK than Italy. Started in central Italy, Belgium, and now is spreading in different countries. And is extremely aggressive. These are the characteristics of race 4, and we see that these are work done in Belgium with low genetic diversity, but higher aggressiveness. What we did in comparison with race 1, which was much more known, and in the case of race 1, the seed industry did work a lot to develop resistant varieties. So when race 4 appeared, it caused some disruption in the market because, of course, most of the varieties which are resistant to race 1 are not resistant to race 4. Vegetative compatibility groups have been studied in the case of all races, and the different isolates coming from different parts of the world belonging to the different races behave in the same way. In the case of Fusarium lactuce, it is important also to use, beside all the molecular tools, the differential cultivars to discriminate among the different races. So we have a number of differential cultivars which are important for this discrimination. And we will get back to the characteristic in terms of temperature requirement of the different races when we will talk about the effect of climate change. So this, at the moment, is an important pathogen. on which the industry, the seed industry, is investing a lot in terms of research of resistant varieties, because of course lettuce is important all over the world. And I must mention that in the case of leafy vegetables and lettuce grown for ready-to-eat salad, we are growing very peculiar varieties with a high number of crop cycles in the same soil. We had also important other wheels that arrived in our country as well in other countries very recently, like the Fusarium oxysporum rafani and conglutinas, which are important on wild and cultivated rockets, so Eruca sativa and Diplotaxon. The Fusarium rafani and conglutinas attacking lamb's lettuce, and then we have the Fusarium oxysporum on endive, the Fusarium oxysporum chicory on cicory, and the more classical, known since many years, the Fusarium spinaceae on spinach. And again, also on this Fusarium, we did work trying to characterize them, and also in order, we will see, to develop diagnostic tools. Another important group of pathogens are alternaria. Alternaria leaf spots are becoming more and more widespread on many crops. Here we are talking about vegetables, but we are seeing in the last years also a lot of alternaria on ornamental crops, on crops where before they were not reported. And this appearance of alternaria leaf spots is mostly linked to the increase in temperature. So we are seeing alternaria leaf spots on different, on leafy vegetables. We are seeing it on basil. These are examples on basil. Has been reported not only in our country, but also in Japan and Israel, on basil grown in soil, on basil grown soilless. And in the case of the alternaria, the characterization of the strains did also take into consideration the production of mycotoxin. Alternaria is known for the production of secondary metabolite, which can be dangerous, and there are several, many, from alternariol to tenosonic acid and others, mycotoxins. And so when we do the identification, the characterization, we are considering the sporulation group, the virulence, and also the production of mycotoxin. Here are strains of alternaria which have been isolated from seeds and plants of rocket, wild and natural rocket. Here we have the characterization of strains of alternaria from different crops, from cauliflower, from rocket, and you see that we are also looking at the production of mycotoxin, and in some cases, some isolates are able to produce in vitro many of the classical alternaria mycotoxins. Here is the production of mycotoxin from isolates of alternaria obtained from basil seeds, and you see that in some cases we have a quite high level of mycotoxin produced. The last pathogen that I'm considering is a pathogen of a peculiar crop, which is very typical of the Mediterranean areas, so for Italy, for France, for Israel, California. Basil. Basil, you know, is grown for fresh consumption, is grown for processing, for producing pesto sauce. And when downy mildew appeared for the first time in Europe in the early 2000s, it was a disaster. Of course, everything is relative. Basil is not a major crop, it's a very peculiar but small crop, but extremely important in several areas, like on the French Riviera, on the Italian Riviera, in Israel, in California. And this disease seems new. It was not new, because downy mildew of basil have been already described in Uganda in the 1930s. And it spread in Africa, but staying kind of endemic in this area. Why? At a certain point, immediately, downy mildew of basil did show up in Europe, first in Switzerland, which is not the first producer of basil in the world, and then in Italy. And in Italy, indeed, in the very first months, it caused a big disruption in the Liguria coast, where we have most of the production of basil for fresh consumption. Because, probably, because the seed production in the last year moved to Africa. We know that many of the companies are producing also for good reasons, mostly for the better climatic reasons. Once, now we have very good climatic condition, very high temperature also here, but the production of many seeds moved to Africa. And with the seeds, we also imported this pathogen that at the beginning was new, and it caused some distress in the very first months. Then, when it was identified, it was possible to develop management strategies, which anyway are not so easy. And when it appeared, Peronospora belbari is causing problems. So it is an interesting pathogen from epidemiological point of view. The temperature requirements are not so high in comparison with other downy mildew, and for instance, in Italy, on the Liguria coast, it spread in the very first year in the fall, with temperature not so high. And this is another pathogen which can be transmitted through seed. Seed contamination had been observed in certain areas, not in all areas, but so this means that treating seeds, which is not easy with the basil seeds, which are again very peculiar, can reduce the disease, but not completely, as we will see. There are different susceptibility in different basil species. Some of the basil species that are used in for medicinal crops are not susceptible, but the basil, Ocimum basilicum, which is used for fresh consumption and for pesto, which is also very much appreciated. We have a very strong selection of varieties used for the fresh consumption and for the pesto production, are extremely susceptible, and it's not very easy to find resistant varieties. So I provide you just some example of pathogens that arrived very recently, in the last 15 years, I would say, with mostly with infected seeds, which are the main challenges. First of all, the effect of climate change, and we will see that some of these pathogens are really favored by higher temperature. We have an increased risk in the production of mycotoxins. We have diagnostic tools that have been developed, but they should be used much more extensively, especially by the industry, the seed industry. The selection of resistant varieties is important, but not always possible. We will see example. We need to manage these diseases with less chemical inputs, not only for environmental reasons, not only for cost reasons, but also because for many crops we don't have chemicals available, or we have very few. So we need to integrate different approaches. We need to prevent these diseases much more than fight against them. And of course, to do so, we need a very good extension services. Just I will focus on some of these aspects. Fusarium wiltoblettius. Fusarium lactuce is a pathogen which needs high temperature. Not very high, but the optimum growth of the pathogen and the best disease in the field is between 20 to 24 degrees. So we need high temperature. And this has been used in the past also to prevent the disease, because in some cases with a delay seeding of the plants, you can reduce the disease. We have the comparison here between race 1 and race 4. Race 1 is the old one, the very widespread. Race 4 is the new one that now is causing more concern. Race 4 is showing a higher aggressiveness in many cases. And what we see of race 4, when we are working, we are looking at the growth, here we are in growth chambers of race 1 and race 4, we see that race 4 is able to cause diseases also at lower temperature. Indeed, if we look when it showed up, it started in Netherlands, in Belgium, in northern countries. Then it arrived also in our region because it's able to grow at the traditional temperature, but is also able to cause damage at lower temperature, and is very aggressive. As I told you, and these are work from, I believe, from the group of Materon in the United States, by moving the planting date, since this pathogen is favored by high temperature, we can also decrease, so we also cultural methods to reduce the damage caused by Fusarium wilt. And in the phytotrons are our machine where we simulate the future weather, where we travel in the future by doubling CO2, that hopefully we will never reach these values, and by increasing the temperature 5 degrees centigrade. When we are looking at the effect, combined effect of increased temperature and of doubling CO2, we see that in most cases, and here we have data on basil, on lettuce, on rocket, cultivated in a white rocket with different pathogens, we see an increase of the disease. So the combination, sometimes the single temperature of CO2 is not affecting, but the combined effect of the increase of temperature and CO2 is increasing the losses. So most of these pathogens will be more important in a future, and not so future, scenario of increased temperature. And I would say even more threatening is the fact that, again, by working in phytotrons under simulated condition of increased temperature and increased CO2, we can observe that we have an increase in the production of mycotoxin, of several mycotoxin. And this, I believe, is the real threat that we will encounter in the next year. So more diseases, but also a higher risk of mycotoxin production. So we need to prevent both disease and mycotoxin production. We have tools for prevention. We have diagnostic tools that have been developed, and of different traditional molecular tools. In the future, probably we will use more and more sensors, but we need to use them, and possibly we need that the seed industry use this test to check the material that they are selling and marketing around the world. Just an example of identification methods that have been developed through the years. These are work in 2007 by Mattias Pasquali on Fusarium lactuce, PCR, and in a way of using specific primers. And the lamp that can be used directly in the field to test the race, to check the presence of race 1 on seeds, soils, and plants. This is a work from Frank Ortega, who is now in the UK, but is here at this meeting. So we have the tools, but these tools must be used, and possibly, I repeat, these tools should be used by the seed industry, also because they know where they are producing the seeds. Genetic resistance is another important tool for controlling these diseases, but not always we have resistant varieties. In the case of lettuce, we have resistant varieties. The industry did invest a lot in obtaining varieties which are resistant, for instance, to race 1 of Fusarium lactuce, and now they are rushing to find varieties resistant to race 4 of Fusarium lactuce, and our group is continuously testing, working in connection with the seed companies to check the resistance to the new races. Here we have example. With rocket is not so easy. Most of the varieties used, and rocket is also a much smaller crop, so there is not so much investment in the search for resistant varieties. So with rocket is more complicated, and most of the variety used are sensitive, susceptible to Fusarium. In the case of Peronospora bar is an interesting story, because there is a lot of research because of the peculiarity of this crop. In California, in Israel, there is a lot of research going on in the search for resistant varieties. The problem is that most of the resistant varieties don't meet the requirement that we ask to basil for fresh consumption and for the pesto material. Especially if you go to people to Genova, you know, they immediately recognize if the basil is not the Genovese gigante that they want. We have in some cases, like the Eleonora, varieties which are tolerant, I would say, mostly because of their conformation of their leaves. So it's much more a physiological tolerance than a genetic resistance. But again, in this field, there is a lot of research going on. We need IPM strategies, and I will show you just because I have to conclude now, because it's true that we have more time, but there is also a second speaker. Just a few examples of IPM. In this case, the use of compost which has been selected, and I must say, this work is prepared also with AgriNewTech, which is a company which has been developed in 2009 by Agrinova, is now an independent company. Compost containing specific microorganisms derived from European project. And you can see with some compost we can reduce the effect of the losses. And again, here we have different kind of compost in comparison with so we are working in infested soil, and we are also working to see what happens to the population of the other microorganisms in the soil. Here we have the use of microorganisms, fusarium against fusarium, against race 1. So we have tools which are different from the chemical traditional tools. And very often it's also important, I go back to this slide, to use compost, to use microorganisms in tray. So very early, because they give protection to the plant later on, and we use very little material in this case. The management of downy mildew is not so easy, because the seeds are complicated, difficult to be treated, because so we need indeed prevention, testing the seeds for the presence of the pathogen, treating the seeds, and then it's very difficult later on to treat the crop, because it's a crop with continuous cropping of leaves, so it's complicated. Indeed, on basil is the best crop, is our model crop for working on different pathogens, but we need really to integrate different methods and a lot also of cultural techniques. So looking ahead, what is important, especially in a field like the vegetable sector, to identify the source of the inoculum, to know from where the pathogen is coming, to use all the prevention methods that are possible, to check the propagating material. We need good diagnostic tools and to use them, and to have the industry especially using them. We need to help the industry to breed varieties which will be the best one in a changing scenario with increased temperature. We need control, we need to strengthen the phytosanitary services, we need good infrastructures, and of course we need to invest in research, in extension service, and in education. All this work has been carried out in many European projects belonging to Horizon 2020, as well as in other projects funded by the local bank foundation. Thank you very much.
Thank you very much indeed, Lodovica. So we now have time for a few questions, of course. Are there any questions from the audience, first of all? Yes, Cindy?
Yes. Thank you very much, Lodovica, for the really comprehensive coverage of the subject, and especially for mentioning CO2. So in your suggestion that people take into account in changing climate in breeding, is there any work being done on also the effect of increasing CO2 on the plant microbe interaction? Not only temperature, because in our lifetimes the CO2 level has changed by 100 ppm, and already. So
yes, and this was done especially on grapevine. Also because, also from our group, because when we started working on the effect of climate change, we started working with more important groups, crops, also to get funded the work, because it's difficult to get funding only for basic or vegetables. So in the case of grape, and of course, there is also an effect on the crop, especially if you work on crop. In the case of vegetable crops, they're very short cycle, but for sure there is also an interaction, and in some cases this is also being evaluated by working on some parameters, yes.
Thank you. Any other question from the audience before we move towards the questions that have been listed in the chat? No? Okay, so I just pick up a few questions from the chat. A first question there was about the arrival, the potential arrival of Fusarium raphani. Did it arrive, or was it pre-existing in soil as a pathogen on cabbage?
Fusarium raphani was already present on other crops, but in these cases it arrived, it also detected on seeds.
Okay. Thank you. There is also a more general question about the import of seeds. So you highlighted, of course, the importance of seeds as a commodity involved in the introduction of these pathogens. So the question is, why do we import so many seeds from developing countries if it is the source of so many new pathogens?
Because, as you know, all the production of propagation material, seeds, and is very much concentrated in a few facilities, because you need a lot of technology. And many of these facilities moved to third countries for several reasons, and which is good because they are bringing technologies, they are bringing work in other countries, in countries where the labor is less expensive, but also the climatic conditions are more favorable to certain crops. So it's a very much, when we think about tulips, or we always think about the Netherlands. In the Netherlands, you are still marketing a lot of material, but the material is produced in other parts of the world, and the concentration is linked to the fact that we need very highly technological facilities. So it's concentrated. The story, I don't want to enter in this discussion because, you know, we have a movement in Italy. We think that you have to produce your own seeds and grow your own, but this is the past. Seeds are produced in few highly technological, and where something can also go wrong, or you can bring to our countries pathogens which are present in other countries. But this is, and in many cases, I know, for instance, in the case of spinach, you need to produce seeds in areas where the climatic conditions are good. I remember a talk from Lindsay Dutoit, where she was explaining why spinach seeds are only produced in some areas. So it's a very much highly technological sector, the one of producing seeds.
Mm-hmm. Thank you. And there is also a comment focusing on basil plant, yes. Still on the commodity trade issue. And the comment is about the fact that there is also movement of plants for basil. And of course, and this could be a quite important pathway for the yes. introduction of the corresponding yes. pathogen. So this, according to that comment, should be taken yes. into account as well. Maybe a last question before we move to the next speaker. At the molecular level, there is a question about the use of the beta-tubulin marker in the goal of the molecular identification of the Alternaria species. Is beta-tubulin sufficient as a single marker for the establishment of the Alternaria species identification? Yeah. Or shall we use other additional markers?
This is the most used, but we can also use other markers.
Mm-hmm. Okay. Thank you very much.
Thank you
again. Thank you very much. So the conclusion is going to be very short, of course, because I guess you are expecting your coffee break very soon. I just wanted to raise after, of course, this information, valuable information that have been shared with the speakers, two major points. First of all, of course, you could see the importance of the trade of plants, of the nature, or what is traded, of course, seeds, which clearly turned out as a key determinant. And this is, I think, a nice anticipation of the upcoming concurrence dedicated to seeds health. So I'm just winking towards these sessions already at this stage. What we can conclude as well is that there's clearly a need of actions at two different levels. First of all, at the upstream level, so Rule clearly illustrated the importance of the risk assessment of at the upstream level, but also, of course, at the downstream level. And saying so, I am of course thinking about the importance of surveillance, and Lodovica also strayed some clear information about this. And talking about surveillance, this is also the opportunity for me to wink at what should have been the talk given by our colleague who unfortunately could not attend. I mean Anna Bourbanos, because he was intended to explain us the importance of the characterization of genomic surveillance, which is going to be in the very, very coming soon, the next future, a key determinant of the surveillance for the future, with a nice, expected nice contribution of course, to the limitation of the risk for the future threats to plant health. And as a last word, I would just also to remind you that there is a huge effort in communication about the risk corresponding to plant health that has been made in the very recent past. If you remember well, the year 2020 has been the International Year for Plant Health, and EPPO has been involved in a very, very active manner during this year in communicating about the importance of this risk. And I am also winking, and this is a more recent issue at EFSA, because if you look at the EFSA website, you will see the nice communication campaign that has been very recently launched regarding the risk regarding the risk corresponding to plant health, or more specifically the risk generated by trade. So that's it for me. Thank you very much again to the speakers for the very nice presentation, and thank you very much to all of you for your contribution. Have a nice coffee break. Thank you.